welcome. In today's video it'll be a short talk about drilling and tapping deep holes, and there'll be a practical demonstration of locating tapped holes when all you've got is the making part. Now, in general terms, they consider tapping deep holes is twice the diameter of the bolt. So if you've got a 3/8 bolt or 10mm, it's going to be 3/4 an inch, 20mm. But on top of that, of course, it's quite an advantage if you actually drill your, assuming the part is thick enough, of course, to take it, drilling the tapping hole much deeper than that. At least another 10mm or 3/8 if you can get away with it. That helps with when you're actually tapping, because sometimes you can quite often get away with just using a taper tap, or certainly you'll get away with it if you own a second tap. The biggest problem that you often encounter is that if people don't drill the hole deeper than they want, obviously you've then got to use a plug tap, as it's known in England, or bottoming tap, other parts of the world, and quite often the chances are that it's when doing that you actually break the tap off, because say that in the past that you've needed every last bit of thread that you could actually get out of a hole, because of the depth of the material, and quite often you grind the end of the plug tap and bottoming tap right down to a real sharp, the first thread. So any little tiny chamfer that was sorry on there is sorry about that, got a bit of a froggy there. As I was saying, if you ground the end of the tap of your bottoming tap right down to a real sharp edge, sometimes that's where the problem comes in. You sometimes you might be a little bit overzealous, and you suddenly hit the bottom before you were expecting it, and of course sometimes a couple of threads actually break off the tap, and of course can get jammed, and of course that's when you get the problem of trying to get it out. You keep wiggling it backwards and forwards and squirting goo in it and all that stuff, but sometimes you just can't get it out and the tap breaks off. So that's certainly an advantage if your material allows it. Drill it way much deeper than you need, and you'll certainly overcome any problems. Now, another thing, of course, is with deep holes is you don't go mad tapping it. I mean, as I say, the recommended tapping depth of a deep hole is twice the diameter of a bolt, because most bolt manufacturers say that the maximum strength that you can achieve from a bolt is one and a half times the diameter. So say if it's a 10mm diameter bolt, well, 15mm, 16mm of thread is the maximum strength you get out of it, and all that you achieve after that is just waste. The other problem that you can encounter is if you try and tap too deep a hole, is sometimes that you can't actually get the bolt in, and you think, well, this is crazy. So you try knuckling it. Well, the nut goes okay. You buzz the tap down the hole again. Yes, it's fine, but you just can't get the bolt in. And of course, what it is, it's manufacturing tolerances. When they're running a batch of bolts, they've got the go no go gauges that they'll spin on the bolt, and also if you've got tapped holes, of course you might have a go no go plug. But the biggest trouble is with that is that they are only 1 to 1.5 times in thickness the diameter of the bolt. So of course, yes, the bolt may screw on, no problems at all, and the plug tap may screw in, no problems at all. But of course, when you try and actually put the bolt into the hole, this is where the manufacturing problems come in, because you get manufacturing problems. You get a creep on the pitch. So you might find that, as I say, the gauge says it's fine, but of course, you know, you get multiple errors. So you try and screw a bolt, say, into a, you know, a 2-inch or a 3-inch deep hole. If you was lucky enough to tap it that long, quite often you find that you can't actually get the bolt in because of the manufacturing tolerances, and also when you're tapping it, you know, the tap can creep a bit, you know, and cut a slightly different pitch than what the bolt is. So just thought I'd pass on that information. Right, I think what we'll do is we'll go out to the workshop, and I'll show you another little tip that's highly recommended for tapped holes, and then I'll do a demonstration of of how you locate holes for drilling and tapping when all you've got is the other part. Join me outside. See you soon. Bye. Now, just to illustrate to some of you that perhaps might not know, this is a complete set of taps. This happens to be half-inch Whitworth. As I say, the top one is the taper tap, this is the second tap, and this is the what's known in England as a plug tap and bottoming tap in the rest of the world. And if they make out this line here, this is where the first thread appears, for the first full diameter of thread appears on the taper tap. This is where it appears on the second tap, and on the bottoming tap, oops, knocked it. It's here. It's still not dead close to the end. It's still about one thread in. But I just thought that I'd illustrate that, so that, like I was saying earlier, if you've drilled your tapping hole deep enough, quite often by the time the taper tap reaches the bottom of the drilled hole, you might have sufficient depth of thread left there that you don't have to bother with putting any other tap in. Now, this set of taps, it applies to all sizes and threads. You know, there's always 3 in a set of hand taps. So say these are hand taps because they've got a square at the end. Just hope that clarifies the situation. We'll continue on later. Now, what I'd like to talk about now is tapped holes in general. See, this is a typical tapped hole. It's got a little shamp around the top, so of course, you know, makes it easy for the bolt to screw in. So you think, well, so what? Well, if I flip it over, I will show you what a professional drilled hole is like. I don't know what you can make of that. You got a beautiful round hole, nice chamfer on the top, and it's also been drilled down about 2 threads clearance diameter. And the reason, well, one of the reasons for that is makes it easy for the bolt to go in. It just drops straight in, you know, no problem at all. Now, the other reason for doing this is that often, if bolts are really tightened up, that there's a possibility that the top thread can actually pull upwards and cause the mating surfaces not to seat properly. So what the idea of this is to say is that by having this recess, any pull up of the top thread, of course, is within this. I mean, it's professionally done. The motor industry, they use it on car engine cylinder blocks. You find all the head bolts are done like that, and also anything that really needs to be mated nice and flat, so that no chance of a burr coming up. Things like gearboxes and stuff like that. So if you've got a chance to do it, I mean, obviously the material's got to be thick enough to that you can actually you know, afford to lose 2 or 3 threads. No problem at all. Just thought I'd like to show you that nice tips. I mean, how much better does that look than that? Yeah. Difference between chalk and cheese, really, isn't it? Anyway, just thought I'd like to show you that. As I say, once again, nice and easy. Bolt drops straight in. So if you're in a funny little place, you know, you're trying to feel, there it is. Your bolt drops in, and you can screw it in straight away. Now, what I intend to show in this little demonstration, I'm only using timber to save my material, but say that you actually want to fit this part to bolt it on.
Now, what I've seen on a lot of YouTube people doing is particularly in America, and it drives me up the wall, is they use transfer punches. The guy will come along and he'll just, you know, stick it down wherever he wants it. He'll pick up his, and I haven't got any transfer punches. I mean, I've never even seen any, let alone actually held one in my hand. But imagine this is a transfer punch. You'll see the guy, he'll stick it in there, bang it with the hammer, stick it in there, do all four, and away you go. Well, of course, the problem, there's two problems with that. I mean, first off, there's no guarantee that after he's banged the first one that he hasn't knocked it a little bit. He does the second one and he knocks it a little bit more. So in the end, none of the holes line up. Now the thing that bugs me is what's the name of it? A transfer punch. Well, it's just a punch. All it's actually doing is putting a mark, hopefully, in the centre of this hole, where you want it to be. But there's no guarantee that it's right. As I say, I consider them highly inaccurate. Now, this actually isn't, say, a transfer punch because I'm possessing it, but this is a drill that's got a fine, whether we can make that. It's a flat bottom drill, and it's actually got this. Sorry, I'm trying to look at this through the bloody viewfinder. It's got a small point on it, so the transfer punch is the same as that. You place it in the hole, and apparently when you've banged it with your hammer, and it's left a little dimple in the middle. Well, for those of you that don't, that perhaps are not engineering orientated, here's a little illustration of what I'm talking about. This is meant to illustrate this is your material, and after you've actually banged it, it gives this little dimple in it, and it raises the surface up on each side. Now that's all very well, providing that you've actually hit it perpendicular to the part. If you happen to have hit it at an angle, as in this one is, I mean, not only is the point now not in this position, but it's raised. It's got a bigger a lump on one side. You know, imagine it as a crater, if you will. You know the impact when something goes in, part of it comes out. Well, if it goes in at an angle, you've got less material on this side than you have on there. So of course the problem then comes is when you come to hit it with your drill, the drill will hit on this side first and tend to want to wander over. I mean, even if you use a spotting drill or a centre drill, there's no guarantee that it won't wander over. So that's why I'm saying this transfer punch lark is a load of hooey to me. Anyway, everybody's got their own opinion of it. So I'm now going to show you a way of positioning your holes without all this transfer punch lark. See you in a moment. Now, just in case those of you that don't know what a centre punch is, it's just a piece of tempered tool steel that's got a point on the end, and it can be a real stubby one like this. It can be a fine one. You know, it's ideally it needs to be something like the drill angle, 115 degrees. But you know, a lot of people, you know, I think this is about 90, and there's one that this little one here is about 60 or so. But as I say, that's what you do. As I say, they come in all sorts of shapes and lengths and whatever, and you just use it for marking your part prior to drilling. Right, now coming back to this demonstration, you know, as I showed you before, you know, it could have moved on with the transfer punch. This is what I would recommend. Position, obviously, get your first hole. Make sure that is where you want it. You know, you position it on there and actually fix it down with a bolt. I mean, this is just a wood screw as an illustration. Tighten that up. Now position it. Get it up nicely positioned where you want it. And what I've actually done is I'll lift it up. Let me show you. When you're happy with it, if you can stand a scratch mark on your part, well, put a nice scratch mark tight on the corners, and you can actually make that out there. I've actually used a Sharpie on here, or a pencil if you don't want to mark it. Make sure that it's fixed down like that. Now the next thing you've got to consider is what size. I mean, these are 3/8 holes here, but I mean your part might only be, I don't know, you know, M3, M4, whatever it is. As I say, take the suitable drill. Say if it's for an M4, well, say pick a 4mm drill, and in this corner, you know, drill it through and penetrate the material underneath by a fair bit, you know, at least a couple of millimetres full diameter, right there. But if this is a big hole, you know, 3/8, ½ inch, it's highly risky when you go to drill this, that, you know, this can suddenly move. So to overcome that matter, I would strongly advise you make yourself up a little drill bush. I mean, this is Delrin, but I mean, you really, you know, don't you know, you want brass or steel, really. That's got to say a smaller hole in it. This has got to say an 1/8 inch hole. Drop it into the part there, and you'll need something to hold it, because otherwise the drill will grab it. So the idea is now is once you're lined up with that, you can put pressure on it, and same with your small drill, drill it through into the part. Then when you're happy with that, you can then obviously remove this, shove this out of the way, drill and tap your proper size hole there, replace it there, and put the proper bolt in. In that way, no way can it move after that. And of course, you can then go on and drill however many other holes there are to be done. Now, the thing is that you've got to consider is that is most important is that if this is your part, if it's say made of plastic, aluminium, brass, copper, and you're drilling into steel, do not use this as the drill jig, because what will happen is when you put your drill in, it'll want to tend to because of the web thickness on the end of your drill, you know, it'll want to wander, and if you don't watch out, you know, you'll chew all your hole up. So if it's that, go for the drill bush idea, and that way you've protected your part. Now, coming back to that last statement of saying that, you know, if it's brass, copper, aluminium, you know, don't do it with steel. It's fine, you know, if this part's aluminium and that part's aluminium, I would go for it. There's very little risk of provided you've got a nice sharp drill, of course. There's hardly any risk of the drill wandering and damaging this hole. So just like to raise that little point. Now, with regard to drilling and tapping holes, I mean if this part is thick, as I say, go down through here with your clearance drill, and take it into the substrate that you're drilling into, you know, 2 to 3 threads deep, and then, as I say, tapping drill and then tap. Always, if possible, try and do the clearance drill first. Even if you're not spotting through, you know, if you're just making a part, I mean, the first stuff you'll do is, you know, is position it, put your clearance drill down, then go down with your tapping drill, tap it, and then obviously you can you know, put your countersink on, you know, break edge, and take it from there. So whenever possible, do your clearance drill first, then the tapping drill, and that way it comes out much better. Whereas if you try and do it the other way, I mean, you know, sometimes when you try and, sorry about that, that's a pilot bloody training again. Yeah, if you try and do it the other way around, the clearance drill can tend to oscillate a bit. You know, if it hits the other smaller hole, you know, it can tend to wander. So the best bet is clearance drill first, tapping drill, tap, and then that's done. Right, I think we will go and get away from this little buzzy aeroplane. Bye. Now, on a final note, as talking about these transfer punches. Now, a transfer punch is totally useless if you've only got thin material. I mean, say you've only got a piece of, I don't know, 1/8 or even less material. Say this, a transfer punch is no good, because the distance from the end of the full diameter to the point is probably thicker than what your material is that you're trying to locate it in. So you know, there's no way in you're ever going to get that to work. So as I say, the only option, as I say, is a little drill guide, and obviously you can, you know, you shift your clamp, you know, much closer to the bottom, you know, to spot through. So that's my little play on my pet hate of transfer punches. I think we've bashed this method, this what's the word I'm looking for? You know, I think I've played the transfer punch whinge to death now. So I think we'll call that it and go inside and conclude this video. See you soon.
So there we are. I hope you enjoyed that little what you've just seen. Now I'm sure I'm going to get a load of flack from our American viewers about me and the you know, transfer punches. But as I say, it's just as I said in the video, it's just a punch, and it's not accurate at all. But I'm sure that I'm going to get replies to say that rubbish. You know, I don't know what I'm talking about. I've done it before. I've left comments on people that use transfer punches, and I get no end of replies. Oh, you're an idiot. You don't know what you're talking about. You know, I've been doing it this way for 30 years, and it's the recommended way. Blah blah blah, and all the rest of it. But anyway, everybody's got their own opinion and way of doing things. But I should certainly carry on the way I'm gonna been doing it of actually spotting through the part. As I say, I've been you know, I've been engineering over 50 years. I said I've never seen a transfer punch, let alone actually have one in my hand. So you know, I'm sure it's just been an American thing, because as I say, coming from England, I've never seen them at all. So anyway, once again, thanks again for watching. Please subscribe, ring the bell, click the like, send me a comment, good or bad. I'm sure I'm going to get quite a few bad ones over this. So until we meet again on the next video, wherever you are in the world, please stay safe, well and happy, and catch you again. Bye!
That's all, folks.